Hi, all right. We're looking at a new topic today. It's called Pythagoras Theorem, and we're going to look at a particular relationship that a Greek mathematician called Pythagoras found with right-angled triangles. So what I'd like you to do is to print out this sheet and then do what I do on the sheet. Okay. Now, for each of the triangles below, complete the table below. Okay. So here's the table down here. We're going to fill in this table according to these triangles. Okay, now these triangles are drawn to scale. It says label the longest side C and the other two shorter sides A and B. Okay, so if we do the first triangle, the longest side is C. Okay, now the two other sides, we've got to label them A and B. It doesn't matter which one's A, which one's B. I'm just going to start with the smallest one there and next biggest one there. So A and B. Let me just draw that A again. So I've labelled the sides A, B, and C. Now, all you've got to do now is go to the table and fill in, for this triangle, what A, B, and C were. So let's do that. Go down to the bottom here. So A was 3, B was 4, and C was 5. Then the next thing to do is to go to the next cell. A squared is 3 squared, which is 9. B squared is 4 squared, which is 16. C squared is 5 squared, which is 25. And then in the final column, you've got to add A squared and B squared. A squared and B squared are these two numbers here. If you add A squared and B squared, you'll get 9 plus 16, which equals 25. Okay, so that's the first triangle done. Now, if you're remembering what squared means, it just means multiply the number by itself. So how did I get 9 here? Well, I got the 9 because it's A squared. A squared is 3 squared, which is 3 times 3. Over here, B squared is 16 because B was 4. So 4 squared is 4 times 4, which is 16. Okay, so that's how I got these numbers. You don't need those there. Just rub those out to keep the table clean for the other triangles. Okay, now let's do the next triangle, triangle number 2. Okay, so we go to triangle number 2, which is this big one here on the right. It says label the longest side C. The longest side has to be C. So you can see on this triangle, 10 is the longest side, so I'll label that C. The other two sides, you can label them A or B, doesn't really matter. So this time, I might label this one A, this one B. I come down to the table, and I fill that in. I had 8, 6, and 10 for my sides, didn't I? 8, 6, and 10 for triangle number 2. Then you've got to work out what A squared, B squared, and C squared are. So A is 8 for the second triangle. 8 squared is 64. Then over here we have B is 6. What's B squared? 6 squared is 6 times 6, which is 36. 10 is C, so C squared is 10 squared. 10 times 10 is 100. Okay, and then next step is to work out what A squared plus B squared is. A squared plus B squared is 64 plus 36, which equals 100. Okay. Next triangle is triangle 3. So let's label the sides A, B, and C again. Now remember, C has to be the longest side. Here is C. And the other two sides, A and B. This time I'm going to call this A and this one B, but you can have that in a different order if you want. Now, let's put that into the table. So A, B, and C is 4.5, 6, and 7.5. So 4.5 here, 6, and 7.5. Now, you've got to work out what those numbers are squared. So A squared will be 4.5 squared. So go into your calculator, press 4.5 squared equals, and you get 20.25. Then we need to work out B squared. B squared is 6 squared, which is 6 times 6, which is 36. And then C squared is 7.5 squared. So use your calculator for that. 7.5 squared, you've got a squared button on there. You get 56.25. Now, if you're wondering where the squared button is on your calculator, here it is. Let's do the last one, which was 7.5 squared. 7.5, the squared button is just here. Squared equals 56.25. Okay, so that's where the squared button is. Okay, now A squared plus B squared. Well, A squared plus B squared is 20.25. So 20.25 plus 36. So add those together, and 36 plus 22.5, 20.25, and you should get 56.25 for that one. So let's write that in there. Keep the colour scheme the same. So this number here should be 56.25 because you're just adding this number and this number. Okay, last triangle. You can see it's triangle number 4 here. Triangle number 4. And I'm going to label the longest side C, just like before, and the two other sides A and B. Okay, so the two sides here are 4.3. 3 sides, sorry. A is 4.3, B is 8, and C is 10.5. So now we're going to work out what those sides are squared. So let's go 4.3 squared. So get your calculator out and work that out. 4.3 squared. So 4.3 squared. That's 18.49. So 18.49 will go into this cell here. And then B squared is, well, B squared is 8 squared, which is 8 times 8, that's 64. C squared is 10.5 squared. So 10.5 squared on the calculator gives us 110.25. And then last of all, we're going to work out A squared plus B squared. So A squared is here, A squared, and B squared is here. Add those two together. So you're going to go 64 plus 18.49. You get 82.49. Okay. Now, let's see if we can see a little pattern here. Now, can you see that this number and this number are the same? Can you see that this number and this number are the same? And can you see that this number and this number are the same? And last of all, let's change colours. Can you see that, I'll do green this one. Can you see that this number and this number are not the same? Okay, so what kind of triangles match triangles 1, 2, and 3? Triangles 1, 2, and 3, we see a pattern, don't we? There's a pattern for triangles 1, 2, 3. The pattern is that the C squared number is equal to the A squared plus B squared number. It doesn't work for the last triangle. Now, if you have a look the first three triangles are right-angled, aren't they? You can see the right angle there, but the fourth triangle is not right-angled. So that pattern of the c squared number equaling the a squared plus b squared number only works for the first three triangles. Those first three triangles are right-angled. It doesn't work for the last triangle. The last triangle, you'll notice, is not right-angled. So what we can say then, if a triangle is right-angled, let's change colours here. If a triangle is right-angled, then the a squared plus b squared number equals the c squared number. Okay? So if you look at the first case, the a squared plus b squared number is 25, and the c squared number is 25. So we can say that the a squared plus the b squared is equal to the c squared number. Okay? Now the longest side we saw is labelled C. The two shortest sides were labelled A and B. Now the other thing to notice is the longest side, which is the C side here, is opposite the right angle. Okay, the longest side is opposite the right angle. Now it's got a special name. The special name for the longest side in a right angle triangle is the hypotenuse. Okay. The other two sides, A and B, we call those the shorter sides. Okay. So the shorter sides are just called A and B. Okay, so now we've got a way of testing if a triangle is right angled. If a triangle is right angled, we know that this is going to be true. So let's look at these triangles down here in this activity. I've got two triangles and I've got a test to see if they are right angled. Now, if they're right angled, then I know that this will be true. A squared plus B squared will be C squared. So let's start off. I'm going to label the longest side on the triangle C, just like before. Actually, that's not the right colour. I wanted this one. So the longest side I'm going to label C. The other two sides, I'll label them A and B. Now, the way you set this out is quite particular. You've got to draw a little table here. The little table will have A squared plus B squared for one heading and C squared for the other heading. Okay, so let's have a look. Here's A, so A squared is 5 squared. Here's B squared. B is 12, so B squared is 12 squared. Now in the other column, we're going to work out what C squared. C is 13, that's 13 squared. We're just going to check to see what happens. Now work out on your calculator what 5 squared plus 12 squared is. Okay, that's equal to 169. And 13 squared on your calculator, 13 squared is equal to 169. Okay, so let's just check it on the calculator so you know how to do it. So the first one we did was 5 squared plus 12 squared. So 5 squared plus 12 squared equals 169. The other one was 13 squared equals 169. Now, you'll notice that both are correct. Both are the same number. So we've got both 169. So what we can say is 5 squared plus 12 squared is equal to 13 squared. Therefore, triangle is right angled. Okay, so that's how you set it out. Okay, so this bit here, the end bit, this bit here is called our conclusion. Okay, so every time you do a question like this, right, this is our little conclusion. And this is our table. So you've got to draw a table, and then you've got to check to see if a squared plus b squared is equal to c squared. If it is, you write this down. Okay, so you need a table and a conclusion for each part of your setting out in these questions. Rightio. Now, let's do the next one. Let's just see if this triangle is right angle. So the longest side I'm going to label C again. The other two sides A and B. Okay, that's the first step. Now, in the working out, just like before, we have the table. The first table has the heading A squared plus B squared. The second has C squared. Rightio. Now, A squared plus B squared. Let's have a look. A squared is 3 squared. B squared is 2 squared. C is 4, so C squared is 4 squared. Now work that out on the calculator. What's 3 squared plus 2 squared? On your calculator, that's going to be 9 plus 4, which is 13. 4 squared is 16. Now, in this case, you can see that these numbers are not the same. Okay, now they're not the same. So you're going to write a conclusion down now. Right, so your conclusion. Right, so there's two parts to your working out. There's the table and then there's the conclusion. All right, for your conclusion. Now you can see that the numbers aren't equal. So I'm going to go 3 squared plus 2 squared is not equal to 4 squared. Therefore, triangle is not right angled. Okay? Triangle is not right angled. Okay? So make this little equal sign with a line through it. That means not equal to. Okay, it means not equal. Okay, so that's how to tell if a triangle is right angled. If the triangle is right angled, then a squared plus b squared will be equal to c squared. But if it's not right angled, you can see that the a squared plus b squared is not equal to the c squared. You'll get two different numbers. If it is right angled, then the numbers will match. Okay, so just in conclusion, you do the table, then you write your conclusion like this. Okay, so that is... Now, if another way you could have written the conclusion alternatively, you might see this in some textbooks. So alternative conclusion to this would be a squared plus b squared equals c squared. Therefore, triangle is right angled. Okay, so that's another way of writing the conclusion you might see in some textbooks. Over here, same thing, but with a not equal sign. You could write it like this, or a squared plus b squared is not equal to c squared, right? And then the conclusion would be, therefore, triangle is not right angled. Okay, so this last bit is an alternative way you could write your conclusion, all right? So that last little bit there is an alternative, and same over here. This last little bit is an alternative way of writing your conclusion. Okay. Now, just one last thing to finish with. I'll show you an incorrect way of setting this out because this is quite popular. And some of you may want to do it, but it's not a good idea because it's not correct. Okay, so what's my... It's a bit messy there. Incorrect. So this is the incorrect method. So this is how some people do it. They'll go, so I'll do the first one, I'll do the second one. A squared plus b squared equals c squared. And let's just do the second one. I would have had sides 3, 2, and 4. Okay, so 3 squared plus 2 squared equals 4 squared. And then you have 9 plus 4 equals 16. 13 equals 16. Okay, and they see that there's two different numbers and they say, therefore, triangle is not right angled. Okay, so therefore, triangle is not right angled. Now, I'll tell you why this is incorrect. Because you can't start off with an equal statement if you don't know they're equal. So we know that 13 is not equal to 16. So you can't start off by saying this is true because we don't know. We're trying to check to see if this, we're trying to check if this is equal to this, right? Because we don't know. So you can't start off by saying they're equal, okay? So the easiest way to avoid using the equal sign incorrectly is just to do the table. Just do 2 columns, you work out what a squared plus b squared is, and in the other column you work out what c squared is, and you see if they're equal, right? And then in your conclusion you write down if they're equal or if they're not equal, okay? So please don't do it like this. This is not correct.